Let me just show you when it might be kind of cool to think of it in terms of x's. I'm just going to do another quick one here. We'll keep it to positives to make it extra clear. And then we'll add to that. I don't know. Give me numbers from 1 to 5.
3.
3.
4.
4 again. And
1.
Okay, cool. So we could be quick with it. Just use your voice here. What's 2x squared and 3x squared make?
5x squared.
5x squared. In fact, I'll just write this answer down because we're already getting so good at this. What does 4x and 4x make?
8x.
8x. And then what's 2 and 1 make?
3.
3. Okay, so we know that's going to be our answer, but allow me to just visualize this one time so you can see why x squareds do not add with x's and why x's do not add with whole numbers here. So for this top equation, let me break it out just a little bit. Oh, I accidentally looks like I took 1x from 4. There we go. That's not how you do subtraction. Okay. So kind of broken it down a little bit here. I'm going to draw 2x. Actually, I'm going to start with 2. I'm just going to draw 2. So here's 1. Here's 2. Those are teeny tiny, right? Those are lines of length 1. They kind of fit into one of those boxes. So each of those, that's a 1, and that's a 1. In fact, they don't need to be the exact size of the box. We can call anything we want 1, as long as we're clear. There's 1. In fact, we'll do vertical. Doesn't matter. Same line, standing up on its legs there. So there's a line of length 1 and a line of length 1. Okay, that's the 2, and then we're going to add to that 4 x's. Now, could x be equal to 1?
Yes.
In some cases.
Maybe.
Right? But could it also not be equal to 1? So I don't know what x is, but I am going to draw it longer than 1. I'm not saying it is definitely a number bigger than 1. I'm just saying that it's, unknown. And in fact, we have 4 of them. So I'll take that last x away and just draw 4 of these lines. Okay, those are not perfectly equal in length, but I think we're going to be okay, huh? I'll redo the last one. That was the bad one. There we go. Okay, so these are each length x. These are each length 1. And then the one that the reason I'm showing you this, the one that students don't really think about too often is, and this is a crappy plus sign. Let's try that again. We'll do a different color. Plus, and then plus here. iPad's giving me too much power, right? Okay, now we need to have 2x squareds. So this is x, right? So I can actually take this x right here, and I'm just going to copy it, paste it. Maybe. You don't let me paste? There it is. Okay, there's my x, and then I'm just going to paste it again, and I'm going to make x squared. So x by x, that's the wrong color. So this is length x by length x. When you multiply 2 x's together, you're making a square that's area is x squared. That's where the word square comes from.
Yeah.
Right, base times height, that's a multiplication. X times x, it's the area of the square. It's x squared. And we have more than one of them, right?
Yeah.
We have 2 of them. So now I'm realizing I could have made that much smaller. Okay, and I'm just going to very quickly do this. It'll let me. All right, here's my 2x squareds. So I have 2x squareds, 4 x's, and 2 1s. And of course, my bottom one isn't going to look quite as good, but I'll add one more 1. Okay, I'm going to add 4 more x's. 1, 2, 3, 4. And then I'm going to add 3 more x squareds. Told you it wasn't going to look as good. I think if I hold it down on a square shape, I literally have to draw something that even kind of resembles a square, and then it'll recognize it. There we go. All right. What was our answer again?
5x squared.
How many squares do you see?
5.
Cool.
8.
8x. How many of these x lines do you see?
8.
8. And then how many of the ones do you see? 3. Again, x could represent anything, but if you're talking measurements, the reason you can't, this is going to get a little spaced out and like physics-y, but the reason you can't combine x squareds and x's is because x squared lives inside 2 dimensions, and x lives inside 1 dimension. And if you've ever been curious what x cubed looks like, well, it looks just like x squared, x by x, but then you add a 3rd dimension that is also length x, and you get yourself a nice cube that is volume x cubed, x by x by x. And can you add cubes to squares? No, you have to live in some weird interdimensional land where dimensions can just play together all kind of neatly. But in math, this is why they say combine like terms. What they really mean is combine terms that exist in the same dimension, the same space. That's like level here for when you would first teach this, but I like the visual because otherwise it just seems like a rule that a math teacher tells you and you're like, okay, why can't I put the 2 and the 4 together? They both have x's or whatever.